Hi everyone, this is your Dr. Biklavin. In this session, we will look into the introduction part of engineering drawing. In this session, I am going to cover what is the importance of engineering drawing, then what exactly the engineering drawing and its importance. Then I move further, what are the equipments required to draw the engineering drawing. Then I move forward, what are the different dimensional systems. Then we will also look into the different types of lines to draw the drawing. So whenever we draw a drawing, so we have different types of lines. Those lines also we will see in this session. Now let me move further to see what exactly I'm going to cover in this, and these are all, as I said just now, I'm going to cover all those. So basically, what exactly drawing means? Uh, Drawing is going to describe an object, information, diagrammically. Some information we are representing diagrammatically. So diagrammatically, that is called the drawing. Some information we have, example, you take some data. Suppose if we plot a graph by using that data, that is called the diagram. Okay, graph is also a diagram. Some data we have, some information we have. So that data, if you want to represent as a diagram or as a figure, is called the drawing. Okay. So one of the most efficient way of communicating is pictorial representation. Suppose if you want to communicate something with others, more information can be presented in a single sheet, or not a single sheet. So whenever we want to represent some information to others, drawing will be the best representation. Okay, so it gives everything. It gives like the comparison, ups and downs, right? How it is moving. How the variation is. So with respect to the different parameters. So that is the drawing. So basically, drawing means describing an object, information, object, information, diagrammatically. Okay. So engineering drawing, as we are the mechanical students, engineering drawing or machine drawing, we have production drawing. So in engineering drawing, we will look into the engineering drawing is going to cover how to draw the ellipse, parabola, hyperbola. Then we will also look into the views, orthographic projections, isometric projections. Then development of surfaces, right? Then sections of solids. This covers all the basic components. Suppose in orthographic projections, we will take some mechanical components, and for that component, we try to draw the front view, side view, and top view. In isometric views, we are going to draw the three-dimensional object from the orthographic projections. So then we will also cover the development of surfaces. Suppose if we assume a, a solid as a thin sheet object, so when you unwrap that, so that how it looks like, so that is called the development of surfaces. So all these will be covered in engineering drawing. Okay. So whereas in machine drawing, which is going to cover the mechanical components, and then we have all the components, right? So when we assemble all those small parts, assume that there are different parts, and when we assemble, so whenever we want to assemble to make a machine or to just to manufacture anything, we require the different parts. So when we assemble all those, so machine drawing is going to cover, so parts will be given to us, and all those parts should be assembled in the case of machine drawing. So whereas in the case of production drawing, so assembled part will be given to us, in which all the parts are assembled, and by looking into that assembled part, we need to extract, we need to draw the drawings of the parts. So that is the difference between the machine drawing and production drawing. So in the case of machine drawing, all the parts will be given to us. All those will be assembled to get one machine or some other component. Okay. So then, if it is a production drawing, assembled part will be given to us, and by looking into that assembled part, we need to draw the drawings of the parts. That is the difference between engineering drawing, machine drawing, and production drawing. Then, as a mechanical engineer, we must know what exactly the engineering drawing, machine drawing, and production drawing. So now, basically, drawing will be the one of the best medium, communication medium. As I said just now, it is a best communication medium. You can easily, I mean, anyone can understand if any of the data is in the form of figure or in the form of pictorial form. Any data which is in the pictorial form can be understood very easily. Okay. So then, okay. So let me take the pointer once again. Okay. Then let me take the arrow itself. So then any of the figure is really gives more information, right? So overall, we need to accept that the drawing will represent more information in a understandable form. That is what we need to accept. So then let me move further. What exactly the application? So let us see the drawings. You can observe here the world's smallest, lightweight, multi-role, supersonic comfort aircraft of the world, as you can see here. So Airbus A380, and these are all the diagrams. Now you can see. So these are all the applications of the drawings. So drawings are, drawings are having applications to draw the mechanical components as well as the buildings. Even you can see here civil structures and mechanical components of the machines. Even you can see here chemical reactors. So you can observe the figure of the chemical reactor here. Then it can be a electrical circuit. So everywhere we require the drawing. So engineering drawing, basically all these are the engineering drawing. But when we are drawing the mechanical components, that is called the mechanical drawing. So when we are drawing the civil structures, that is called the civil drawing. When we draw the electrical circuits, that is called the electrical drawing. So like this, we have some specific application. So everywhere drawing is having application. So with respect to the application, we are calling as a civil engineering drawing, mechanical engineering drawing, electrical engineering drawing. So every engineer must require the drawing knowledge. Either engineer can be civil engineer, electrical engineer, mechanical engineer, or electronics engineer. So everywhere we require the engineering drawing. So then, as I said, a graphical representation of an object, either it can be a graphical representation of the data, can also be called as a drawing. But whereas in this case, is trying to define graphical representation of an object is called drawing. Okay. So it can also be, I would like to emphasize you that, so drawing can be the representation of the data. Suppose if you represent some data in the form of graph, that is also a drawing. So not only an object, so the data can also be represented in the form of figure, in the form of drawing. Okay. So when it comes to the engineering drawing, a drawing of an object that contains all the information, because we are specifically sticking to the engineering drawing. So a drawing of an object, every drawing of an object must contain all the information. Now, information means like its length, width, height, surface roughness value. Every surface is having some surface roughness values, means irregularities. Then what exactly the shape, accurate size, manufacturing method. Even the drawing must have the manufacturing method. Okay. So no construction or manufacturing of any engineering objects is possible without engineering drawing. So that means if you want to construct a bridge, or if you want to construct a any big building or any of the construction without the engineering drawing, I hope it is not possible to construct. So without the engineering drawing, it is not possible to construct any structure, or it is not possible to manufacture any component. Then how this engineering drawing is different from artistic drawing. So artistic drawing is different, engineering drawing is different. So engineering drawing is completely different from artistic drawing, as I said, so which are used to express the aesthetic, physiological, and abstract ideas. Okay, so the artistic drawing is basically used to express the aesthetic, philosophical, uh, and abstract of ideas. Suppose you got some idea in your brain, so you can represent that as a figure. So that figure is different from the engineering drawing. Okay. So then engineering drawing has a specific calculation base. Suppose if you want to construct a base, or if you want to construct a house, it requires number of drawings, right? So it requires some calculation. That means engineering drawing requires calculation, but whereas the artistic drawing doesn't require any calculation. That is the basic difference between the artistic drawing and the engineering drawing. Engineering drawing requires the calculation. Engineering drawing totally depends on the calculations, whereas the artistic drawing doesn't require any calculation. Suppose if you get an idea, if you put that on paper, that is called the artistic drawing. Suppose if you want to draw the a tree, suppose if you want to draw the, any of the structure or any of the object, if you have something in your brain, if you put that on the paper, or if you want to draw that on paper, that is called the artistic drawing. But engineering drawing, we cannot draw like that. Every line is having dimension. Everything, whatever we are representing on the paper, is specifically related to the calculations. Then that is the difference between artistic drawing and engineering drawing. Now, what is the, I mean, different types of engineering. Even engineering drawings can also be manual drawing. It can also be the computer-aided drafting. So CAD drawing and manual drawing. But in the olden days, everything will be manual, manual production drawing, assembly drawing, then machine drawing, production drawing, engineering drawing. Everything will be manually drawn. But whereas nowadays computers are assisted to for the drawing, so that we are calling as a computer aided drafting. So now let me move further. Items required for drawing. There are different items are required. So drawing board is basically we require drawing sheet. We require on which we are going to draw the actual drawing. Mini drafter we require. I will show you all the figures of all these components are the items required for drawing the engineering drawing. A mini drafter we require a drafting machine, otherwise we require the drafting machine T-square we require. Then instrument box which consists the compass, divider, then compass, divider. We also require the scale, right? Protractor, French curves we require, then drawing pencils we require, eraser, clips we require, sharpener, then eraser, everything. These are all the items required if you want to draw the engineering drawing manually. Suppose if you want to draw any of the engineering drawing we require, that can be any of the engineering drawing, machine drawing, production drawing, uh, or any of the civil engineering drawing, any of the drawing, if you want to draw manually, these are the items required. A drawing board, drawing sheet, mini drafter, instrument box, compass box, otherwise in general term is compass box, which consists the divider, right? Divider, compass, then scales, protractor, French curves, drawing pencils, eraser, drawing clips we require to hold the sheet on the drawing board. Drawing clips are required to locate or to place the drawing sheet on the drawing board, and sharpener we require so to sharp the pencil. So these are all the instruments so deadly required to perform the engineering drawing or to draw the engineering drawing. So now let us see all these figures. As I said in the last slide, so drawing boards we require. Drawing boards are available, commercially available in the market in the different sizes, B0 to B3, B0, B1, B2, and B3. B0 size is 1000 to 1500 millimeters, and B1 is 700 to 1000 millimeters, B2 is 500 to 700, and 350 to 500 millimeters. So out of all these, B1 size is mostly used. So 1 meter and 700. 700 and 1000 millimeters is mostly used by the most of the draftsmen will use this type of board, this size of board. Okay. This drawing board must be placed on the table. So table which with working edge always be at the left side, of course. So this will be the working edge. So on the top, we are going to fix the mini drafter. We will see what exactly the mini drafter in the coming slides. Then this drawing board must be placed on the drawing table. By standing, we are going to draw the engineering drawing. Okay. So last two sizes are normally used for the student drawing, but when it comes to the offices, so 700 to 1000 will be the optimum size. Okay, so now let us see what is a mini drafter. So miniature version of the drafting machine that you can see here. So this consists of a clamping screw and clamp. This is exactly going to fit at the top left corner of the drawing board. That means this clamp and clamping screw is going to fit at the top left corner of the drawing board, exactly at this location. Assume that this blue colored border is a board. Then this top left corner, exactly at the top left corner, this mini drafter clamp will be fixed. So this mini drafter consists the double parallelogram of bars. So as you can see here. So here you have parallelogram of bars, and here also you have, and these four bars are hinged at this location. Okay. So then the one end of this double parallelogram of bars is connected to the clamp, and other one is connected to the scales, which are perpendicular to each other. The vertical lines will be drawn by using this scale, and we have the other scale that is used to draw the horizontal lines, normally in the zero position. So here also you have protractor head. So whenever we want to draw the inclined lines, so these two scales will be twisted or rotated to the desired angle, and using these edges we are going to draw the inclined lines on the drawing sheet. So horizontal and vertical lines can be drawn using these two horizontal and vertical scales, which are connected to the protractor head, and at the middle of this we have a knob. When we fix this knob, at any of the desired position we can fix these two scales. Okay. So after rotating the desired angle, and this will be fixed, and this knob will be tightened. Then after completing our drawing, that means suppose if you want to draw the 60 degrees angle, so this scale will be twisted to, so we are going to unlock this knob, then we rotate these two scales to the desired angle, then we tight this knob. After drawing the desired angle, then we are going to unlock this knob, untight this knob, then we will bring back these two scales to the original position or the zero position. So we have a zero mark here, exactly. So when we adjust these two scales at the mark of this knob, so exactly our lines, this scale will be horizontal, this scale will be vertical. So as I said, these two are the double parallelogram of bars will be pivoted or hinged at this location. So when we fix this clamp at the top left corner, it is having a degree of freedom to move on this horizontal plane. So these two scales can be moved on this drawing plane at any of the drawing plane. This is what the mini drafter. Then this is the main instrument used to draw the engineering drawing. So as I said just now, this mini drafter should be placed on the drawing table, as you can see here. So this is the mini drafter. This is placed on the drawing table, as you can see here. Even this drawing board can be twisted to any of the desired angle. So this drawing table is having that provision to rotate, even to change the inclination of the drawing board. Then I said just now, you can see this drawing sheet will be placed on the drawing board. This drawing board is placed on the drawing table. Then I said with you just now, at the top left corner, mini drafter clamp will be fixed exactly at this location. Okay. So this uh, double parallelograms are hinged at this location so that you can move this two scales. One is horizontal and vertical at any of the position on the drawing sheet. This is how the drawing board, drawing sheet, and drawing table looks like. Then let me move further to see what are the different items, are the instruments used in engineering drawing. Then the compass, we also have the set squares, as you can see here. One is 30-60 and the other one is 45-45. So these are available in the compass, as well as these two are also available in big size. Individually also we can purchase. Then we have the French curves. As you can see here, we have the depressions here, and we have the scales like this. So these curves, French curves, are used to draw the curves whenever we want to connect the 2 points as a smooth curve. So these French curves are used. So whenever we want to connect, whenever we want to join the 2 points as a smooth curve, so in that case, these French curves are extremely useful. So instead of joining the points manually by the hand, these French curves are used to draw the curves, are used to join the points where we require the smooth curve. This is what the importance of the French curves. Now we have the drawing clips. As I said just now, drawing clips are going to hold the drawing sheet on the drawing board firmly, so without moving. So as you can see here. Then we have the compass. So compass is also required to locate the points at a desired angle. Okay, to draw the lines at the desired angle, we need to measure the angles first. So these compasses are used to draw and as well as measure and as well as to draw the inclined lines. Okay, so then basically these are used to measure the inclination between the lines, or to measure the inclination mm, at the desired location. Now let me move further. As I said, we require the set squares. These are called the set squares. These are called the French curves. These are called the compass, and these are the drawing clips. So all these will also comes under the drawing instruments. Now the drawing sheets are available in different sizes, A4 to A0 to A4 sizes. A0 is trimmed and untrimmed size. Trimmed means some extent we have some reduced size. So after trimming means after cutting, the edges will be trimmed. So in the untrimmed size, it will be 880 by 1230. If it is trimmed, 841 by 1180. Then, as you can see here, A4 210 to 297, 240 to 330. These are the standard sizes of the drawing sheets available. Then let me move further. The layout of the drawing sheet. As you can see here, this is exactly the drawing sheet. So before starting the drawing, we must draw the borders first. So you can see here, the borders are available here. So from the left side of the trimmed edge, so we must leave the 20 mm from the left side edge. Okay. Then we must also draw the frame. So we can see here, we must also the frame or the border. To some extent, we can say there's a border also. So as you can see here, 20 mm from the left and right. Then this margin is called the filing margin. Suppose if you file this drawing sheet, so we require some margin to tag the sheets. Then this border or uh, this frame is around 5 millimeters width. Then inside this also, so there is one block at the bottom right corner. There is one block. So this block is called the title block. The width of this title block is around 170 millimeters, maximum 170 millimeters. The height will be around 60 to 80 millimeters. So normally 60 to 65 will be preferred. It looks good. 170 will be the optimum length of this title block, and height will be 60 to 65 or 70 to some extent. So this is how this layout of the drawing sheet looks like. So we will see in detail while starting the actual engineering drawing. Then I move forward to see the different types of pencils we need to purchase. In engineering drawing, we prefer to use the wooden pencils. These wooden pencils are available in the market with numericals followed by a numeric followed by the alphabet, as you can see here. So 7B, 6B, 5B, 4B, like this. So these are in the decreasing order of softness and the dark and the blackness or the darkness. Then H to 9H, increasing order of hardness. Okay, these are the increasing order of hardness. Drawings are done using 2H pencils. The actual drawings will be drawn by using the 2H pencils. But H and HB pencils will be used, will be practiced in this course. Basically, drawings are done using the 2H pencils and finished. Basically, actual drawings will be drawn with 2H pencils and finished with H and 2H pencils. So if you want to finish the drawing, so in that case, we are going to use H and HB pencils in this course. Now, let us discuss how many lines are used in any of the drawing, engineering drawing. So there are some lines which are used to indicate the dimension. Those lines are called the dimension lines. Okay. So then there are some lines required to indicate the dimension. Those are called the extension lines. As you can see here, to indicate the length of this block, to indicate the dimension of this block, we require the extension lines. Okay. So in between the extension lines, the dimension lines will be drawn. Then there are some cases, holes and cylindrical or symmetrical components. Sometimes we require to indicate the center line. As you can see here, we have a hole here. So this hole is required to show the center. As you can see here, this is the center. This is also the center line. This is also the center line. And these two are located these two holes are also drilled cylindrically. It also required to indicate the center line. Okay. So then, as you can see here, so if you do any section. So that section surface needs to be represented like this. So there are some inclined lines. So these are at 45 degrees. Angle with some space, preferably around 2 to 3 millimeters, as you can see here. So section lines, as I said, 0.3 are 35 millimeters. 35 millimeters. Okay. So then, as you can see here, this is the actual line of the component, visible line of the component. And there are some surfaces which you cannot see. There are some edges of the component, those we cannot see in our view. In that case, we need to represent those edges as the dotted line, as you can see here. So this edge, basically this is an edge inside this component that you cannot see. So that line needs to be represented as the dashed line. So dashed lines are going to represent the edges which you cannot see. Those edges will be drawn as the dashed line, as you can see. Then you have the cutting plane. This A will represent the cutting plane. That means we are representing. So when you make section here, so you have the section, cross section here. When you make section here, it looks like section A. So when you do section here, it looks like this. So when you do section here, the shape is different. So we are representing. So when you do section at AA, so the cross section will be like this. When you do section at this location BB, the section cross section is different. It looks like this. So these are the different lines we come across while drawing. We need to use while drawing the engineering drawing. As you can see here, dotted line, dashed line, center line, then section lines, visible lines, then dimension lines, extension lines. So all these are then cutting planes, center lines, as you can see here. So all these are the lines that we have to use in future. Then let us see what is the standards and conventions. We have some standards and convention to represent. Even the dimension, even the surface roughness values. So there are some conventions, are the standards we are going to use to maintain uniformity, so which might be understood by all the users. So if we use the same convention across the globe, anybody can understand. So that there are some standards in engineering drawing. Those standards we see in these slides. So as you can see, the convention, dashed line are used to represent the hidden features of engineering drawing. As I said just now, so the edges are the holes, are the surfaces that you cannot see. Not the surfaces, the edges that you cannot see will be represented as the dotted lines, as you can see here. In this case, you have a hole here, and this hole we cannot see. So this will be represented as the dotted line. This edge you cannot see. So then, as you can see here, in this case also you can see the dotted lines, dashed lines you can see. You have some surface roughness values you can see. Center lines, extension lines you can see, the dimension lines, all you can see here. Section lines also you can observe here. Right. So all these are the different standards, and even you can see here the section plane here you can see. There are some drawing standards also. Every globe is following some drawing standards. ANSI, American National Standard, they are using some conventions. So in this case, 14.1 1980 drawing sheet size. This is going to indicate the drawing size. Then conventions and lettering. So this is going to indicate. So ISO means International Standard Organization. As you are fully aware, International Standard Organization. Then JS means Japanese standards. Then we have the BIS, Bureau of Indian Standards. All these are the abbreviations normally we come across in the drawing textbooks. We need to remember this. ANSI means American National Standards. institutes, and ISO means International Standards Organization. JS means Japanese Standards. BIS means Bureau of Indian Standards. Then we also come across the different shapes in drawing, and acute, obtuse angles, less than, more than 90 degrees, right angle, rectangle, square, rhombus, trapezoid, okay, trapezium, pentagon, hexagon, heptagon, octagon. Octagon means it is having the 8 sides. Heptagon means 7 sides, 7 equal sides, as you can see here. Hexagon means it is formed with the 6 sides, and pentagon 5 sides. So decagon means 10 sides. Okay. So all these are, shapes we need to remember. The terminology also we need to remember, which are extremely useful. Tetrahedron is the pyramid which is having the four triangular surfaces which are equal in its size. So then these are all the, as you can see here, we have the cones you can see here, cones, pyramids, then torus you can see here, spear, then frustrum and truncated cone, frustrum of the cone and truncated cone. So frustrum of the cone means the top. So the cone is sectioned such that the section plane is parallel to the base of the cone. Then truncated means the section plane. That means the section plane is not going to make the section parallel to the base of the cone or pyramid. So frustrum of the cone or frustrum of the pyramid. In the case of the frustrum of the cone or pyramid, the section plane and base is parallel. Whereas the truncated, the section plane is not parallel to the base. So these are all the different shapes we come across in engineering drawing. We will see in detail when we come across about all these shapes in future. Then let us see what is, there are some practices, routine practices to represent the dimensions. As you can see here, a plate is having 2 holes here. Its dimension is represented exactly in the front view. And this will be the front view and this will be the top view. So on the top view, it is represented here. So then you can see here, it is a bad practice to represent the dimension at this location. It is better to represent. So wherever these holes are, we have the better visibility. At that location, we need to represent the dimension. Then I move forward. Even in this case also, you can observe here half dimension you can see here. It's the best practice. It is not supposed to indicate the dimension in the sectioned lines. Of course, this is some extent it is okay because you are breaking all the lines and you are representing the dimension. So you are not breaking all these section lines and you are representing the dimension. So it is a bad practice. So these two can be accepted. It is the best practice. It is okay, but it is not accepted. Now, even you can see here staggered numericals. Because here you can see here. So here you can find three steps. The outer dimension you are representing here, the middle dimension you are represented here, the top portion dimension you are represented, and these 3 dimensions are represented at the same location. This is, it gives some not clarity while reading these dimensions. Definitely the observer or the reader is going to confuse. So to avoid that, this must be located somewhere. That means this needs to be staggered, okay, zigzag manner. Otherwise, if you represent the dimensions like this, it is very comfortable to read by the observer or by the person who is observing the dimension. This is preferred version and this is not preferred. This is a poor practice. This is preferred practice. So the dimensions where you have the more number of dimensions, so we need to stagger those dimensions. So then let us come back to the how do you represent the arrow marks. There are different types of arrow marks that you can see here. So normally the arrow mark size is 3 mm wide and 1/3 of the wide. So 3 mm wide and 1/3. So 1:3, as you can see here, or 3:1. So when the length of the arrow is 3, so the width must be 1 mm. If it is 6, if it is 6, now as you can see here, it is 3W means it is W. That means the size of the length of the arrow and width of the arrow must be 3:1. So as I said just now, the width of the arrow is 3:1. Width of the arrow is, and the ratio of the length to width is 3:1. So when we take this length as 3, the height or the width should be 1. If it is 6, so the height should be 2. Okay, so 2 millimeters. So this, if it is 2 millimeters, if it is 6, if the length is 6, the height should be 2 millimeters, like this. If it is 3, it should be 1 millimeter. So there are different types of arrows. One is open-ended arrow, closed-ended arrow, closed and filled arrow. As you can see here, there are, I mean, normally we draw these three types. One is open-ended, closed, closed and filled, closed and filled. So these three we are going to use, and try to remember this ratio. 3:1 is the ratio. Then let me move further. There are different dimensioning systems. One is aligned method, the other one is unidirectional. So in these methods of dimensioning, in the case of aligned method of dimensioning, the dimension values read from the bottom as well as from the right. So from the bottom and right, we are going to read the dimensions in this aligned method of dimension. Whereas in the case of unidirectional method, in a single direction, we are going to read, as you can see here. So from the bottom, we need to read in a single direction, or in a single view, we can read the dimensions. You can see here. So dimension values read from the bottom and as well as the right, or from the left also. So in the case of the unidirectional, it is only going to read from the bottom. Now, there are two angles of projections, popularly first angle projection and third angle projection. So in the case of first angle projection, the top view will be shown at the bottom, and the side views will be left side will be drawn at the right side will be drawn at the left side in the case of first angle projection. So I will tell you why we are going to represent this top view at the bottom. Okay, left side view, right side will be drawn at the left side. Okay, then in the case of third angle projection, so top view will be drawn at the top and left side view will be drawn at the left and right side will be drawn at the right side. Okay. So these are the first, two angle of projections used to represent the figures, represent the views otherwise. The first angle projection and third angle projection. Okay. As of now, you try to remember in the case of first angle projection, top view will be drawn at the bottom. That means below the front view, left side will be drawn at the right side view will be drawn at the left side. Then in the case of third angle projection, top view will be drawn at on the top of the front view. I mean, with respect to the front view we are talking. Okay. So the top view will be drawn above the front view. Right side view will be drawn right side to the front view. Left side will be the left side. Whereas in the case of first angle projection, it is vice versa. Top view will be drawn to the bottom of the front view. Left side will be drawn right side will be drawn left side. Like this. So thank you for this session. This is all the different equipments required, fundamentals, what is the importance, what is engineering drawing, what is artistic drawing, then what are the different dimensioning methods we have seen, what are different lines, what are different shapes we have seen in this session. So thank you for this session. Thank you one and all.